Okay, good morning children. Class 7 maths. Here we are again. Now we are going to do chapter 10. Name of the chapter is simpler linear equations in one variable. Pardon my handwriting. Okay, now this is a continuation with algebra only. Simple concepts are there. I'm just going to explain a few, then we move on to sums if time permits us today. Right. So let me just write a few. We call it equations only. 8 plus 5 equals to 13. Number 2. 7 minus 4 is equal to 3. 7 minus 3 is equal to 4. Okay. Then let's call it the third one. Third one I would like to write 3 into 4 is lesser than 17. Then no, this will not be the third one. The third one will be 6 plus x equals 11. Okay. And we have the fourth one. The fourth one we are going to write what I wrote right now. 4 is lesser than 17. And the fifth one, x is greater than 7. Sixth one, x is not equal to 4. Okay, now look at these equations. We have 1, 2, 3, 4, 5, 6. There's a reason why I've done 6 equations. Okay, a little bit of an introduction in maths, a little bit of theory. These statements, I think it's 1, 2, and 3. Okay, these statements state that two numbers given on the two sides of the symbol are equal. That's very true. If you add 8 plus 5, it will be 13. If you subtract 3 from 7, it will be 4. Okay, and what will be the value of, okay, this I'll come to this later. Okay, now the other ones, 3 into 4 is lesser than 17, x is greater than 7, x is not equal to 4. Okay, these indicate that numbers given on the two sides are not equal. They cannot be equal. There's no equal to sign. Okay, so a statement of equality like this, 6 plus x is equal to 11, okay, given in number 3, which contains an unknown quantity, okay, is called an equation. Okay, that's what the book says, right? A statement of equality like 6 plus x is equal to 11, where it contains an unknown quantity, okay, is called an equation, right? Statements like x is greater than 4, or I'm just quoting by the book because it will be easier for you to think, that is given are called inequalities or inequations. Okay, this is the basic difference. This is called an equation, this is called an inequality or equation. Okay, so the book states an equation states that one expression names the same number as another expression. It contains the sign of equality in it. Okay, it says an equation states that one expression names the same number as another equation. Okay, this is called, it contains the sign of equality in it, right? That's what the book says. An inequality like these, an inequality states that one expression does not name the same number as another expression. They are not equal to each other. So that's what the statement is trying to tell you. It contains the not equal to sign, or greater than sign, or lesser than sign, right? So any equation, it contains two sides. There is a left hand side, we'll call it as LHS, there's a call it RHS. Okay, for example, this equation x minus 2 is equal to 7. Okay, so this becomes the right hand side This becomes the left hand side, that is divided by n equal to sign. Okay. Now this is just an introduction for you children. We will be doing the computing later on. Just wanted to let you know a little bit of theory. Okay, when I do the sum, this left hand side, right hand side concept is very important, because whatever we need to find out, we'll keep it on the left hand side. Whatever we can find, with the help of which we can find it, we'll send it to the right hand side. Then we'll get the value. Okay, now this is another term. These are theoretical terms, but it's better that you know whenever we do sums, we are not going to write all these things, but still it was there in the book, so I thought it will be better if I let you know. Solution or root. Solution or root of an equation. Okay, interesting. Book says a number which satisfies an equation is called the solution or root of the equation. That means whenever we come to the final solution. Okay. For example, the solution of the equation 5 plus x is equal to 7. 5 plus x is equal to 7. They say the solution is 2. Very true. How? Because as I told you, we need to find out whatever is there. Whatever we need to find out, we keep it on the left hand side. Whatever we have to find out, with the help of which we can find out, like this 5 will go to the other side. And please remember, when the numbers jump from one side to another side, the sign changes. So 7 minus 5, this is 2. Okay, so the book says the solution of the equation 5 plus x is 2. In other words, the value of x, called the variable which makes the given equation a true statement, is the solution of the equation. This is the solution of the equation. Okay, let's go to another example. It states, if you want to check whether x equals to 2 is a root of the equation, okay, let's say in a thing x is given as 2. Okay, so we want to find out whether it's true or not. Okay, so it says if you want to check whether x is equal to 2 is the root of an equation 4x plus 3 is equal to 11. Okay, you want to check whether it's true or not. So substitute the value of x. So this will be 4 into 2 plus 3 is equal to 11. Okay, so 4 2s are 8 plus 3 is equal to 11. 8 plus 3 is 11 is equal to. Understood? So hence x equals to 2 is the solution of the root of a given equation. That's true. X is 2. If x is 2, then only both sides will be equal to each other. That's why I told you that time when we have an equation, both the sides will have to be equal to each other. Okay. Now, so these are a little bit of theory. This is another beautiful example. It says, see, both the sides will have to be equal to each other, then only it will be an equation, otherwise it will be an inequality. Okay, so simple example given in the book is there is a pan, okay, like your, I think this is your physical balance, right? Okay, the book says you can compare an equation with a pair of pans of a balance, of physical balance, just as the beam of the balance remains horizontal when equal weights are placed in two pans. That's true. If you go for shopping, whatever, I think, I don't know how many shops still use this, because we have electronic weighing meters already, okay, but still, physical balance, if it's been used, beam balance, physical balance, right? The whole concept is whatever you have to buy, let's say you want to buy 5 kgs of potatoes, you put a 5 kg weight out here, and you put the amount, the potatoes, you keep putting here till the time the bar becomes horizontal or parallel to the ground, then you know that it's equal in weight. If it goes up and down, if it goes down, that means the amount of potatoes or the object that you're buying is more. If it goes up, that means it's less, you need to bring it at the equal level. Okay, so you can use this concept in this solving linear equations. Okay, So just as the beam balance remains horizontal when equal weights are placed in two pans, in the same manner the two sides of an equation are equal when we have the equal numbers on both the sides. Okay. Suppose you have x kg apples. Okay. Now you have x kg apples out here. I'm just going by the book, okay, because you'll be using the book. Suppose you have x kg apples in the left hand side of a pan and you require 6 kgs. Okay, you require 6 kgs to put in the right hand side of the pan to keep the scales in a balanced position. Then you can say x equals to 6 kgs. Understood? So are you getting it? Okay, I'll just repeat it again. Suppose you have x kgs of apple. You don't know how many apples, what is the weight of the apples. You have quite some number, like 10, 15 apples with you. Okay, but when you put 6 kg on the other side, when this beam becomes horizontal, or the spans balance each other and they are equal, okay, then we can assume that x is nothing but 6 kg. That means there are 6 kgs of apple. Okay, now comes the interesting part. If you take, now just remember this, okay, x equals to 6 kgs. If you take away 2 kg apples from the left pan, okay, so from this side, if you do x minus 2, what will happen? The pan will start tilting. This will go down, this will go up. So in order to compensate for that, what do? From this 6 also, you have to remove 2 kgs, right? So it says, if you take away 2 kg apples from the left pan, the balance would dip to the right. Okay, obviously it will dip to the right. Okay, children, this is the right hand side. This is the left hand side. Okay, the pan will dip to the right. It will return to the original position if you remove the same number of kilograms, that is 2 kilograms weight from the right pan. Okay, so we have an equation, x minus 2 is equal to 6 minus 2, right? So x minus 2 is equal to 4. Okay, now if you take if you have to find the balance, the value of x, it will be 4 plus 2, 6 again. Okay, next part. If you put 5 kgs, if you put 5 kg apples more on the left, now this is x plus 5 kg. Okay, on the left, the balance would dip to the left. Obviously it will be heavier this side. On left hand side it will go down, and you will bring it, okay, dip to the left. And to bring it back to the horizontal position, what you have to do, this side also you'll have to add 5 kgs, right? So counterbalance, and it becomes horizontal. You will have to put 5 kilograms of weight more on the right pan. Then you can say x plus 5 is equal to 6 plus 5, right? So x, this, if you have to, in this book they haven't gone all the way, okay. So x is equal to, x plus 5 is equal to 11. Now x equals to, you have to compute it further. Okay, understood. So I get, see, I told you that's why to pay attention and concentrate on this part. See, we're trying to bring it equal. We're just trying to bring it to the originally the way it was. If it goes up and down, what do you have to do to bring it to the base? It's not given in the book. I'm just going into a little bit further. Okay, now the next point that's given out there in the book is, if we double the quantity of apples then we will have to double the weight in the right pan also to keep the beam in the bench. Okay, so out here, let's say we double, that means 2x. So out here, so it will be 2 into 6. Okay, so 2x equals to 2 into 6, that means 2x equals to 12, x equals to 12 divided by 2. Are you getting it? We subtracted, we added, we multiplied. Now we'll go to division. Okay, now let's go to the last part. It says if we halve the quantity of apples, that means whatever x kgs of apples, if we halve it, make it into half, remove half of it, 50% if we remove it. If we halve the quantity of apples, we will have to halve the weight also to keep the balance in the horizontal position. Okay, so x divided by 2, that means halving it. Okay, this will also will have to, right. So we come to the equation x divided by 2 equals to 6 by 2, right, or this will be thing. So x divided by 2 is equal to 3, or x equals to 2 goes this side, 3 into 2, again we have 6. See, all when we subtracted, when we added, when we multiplied, and when we divided, everything is coming down to 6, the original value. That's why I told you to pay attention to this original value. Understood? So this is the concept given in the book. So with this all, we can come to the conclusion. What is the conclusion that we can come to? Page number 167. The same number can be added to both sides of an equation. Similarly, the same number can be subtracted from both sides of an equation. I have already shown you. You can go back on the video. Both sides of an equation can be multiplied by the same number. Very true. Both sides of an equation can be divided by the same number. Very true. Understood? So going this way, you can see how we can go about solving the problem. Right? So I'll just do one example from the book, then we will start doing the sums from exercise 10A, if I'm not mistaken, because after 90 it should be 10 only, right? So I'm doing this example on page number 167, example 1. Okay, so x plus 4 is equal to 12. Okay, now look here, x plus 4 is equal to 12. So you either subtract 4 from each side. Okay, I'm not going to do that because though the whole idea is to bring it to the same number or to bring it to the same solution, but sometimes some children, some of you get maths easily, some of you don't get maths easily. Ultimately everybody gets it, but when you hear it for the first time, how quickly you pick up, okay, that differs from a child to child. That doesn't mean that one child is better than the other. Some take time, people, we have been designed differently, right? Each individual is totally different. Though you are a product of your parents, you are totally different from them. You will not be exactly identical to your father or your mother. You will be a unique piece of art, right? So that's the beauty of creation or evolution, whatever you would call it. So what would we do out here? X equals to 12, this 4 goes that side, minus 4, so 12 minus 4 would be 8. Okay, so let me see. It says explanation, you want only x to remain on the left hand side. So this is your left hand side again, children, this is your right hand side. You want only x to remain on the left hand side. To have this, you will have to subtract 4 to keep the quantity equation balanced. You will have to subtract 4 from the right side also, which I did not do. Okay, what they are trying to tell you is x plus 4 minus 4 is equal to 12 minus 4. The whole thing comes down to this only, right? Okay, so this will be x equals to 4 plus 4 minus 4 is 0, 12 minus 4 is 8. Understood, children? But I think it's better that I do it this way. It's easier to explain also, because later on you will be doing this in maths, right? Okay, so let me see if this couple of examples that I can do. Okay, so thus a term, see, this is called transposition also. We'll be doing that in, I think, the first sum of 10A. Thus a term may be transported from one side of the equation to the other side, but its sign will change. This is the rule of transposition. So a term may be transposed from one side, from the left hand side to the right hand side. When it goes, the sign, it was plus, it becomes minus. Okay, now let's move on to exercise 10A. Okay, so number 1, it states solve the following equations by transposition. Check your answer. Okay, so x, I think the first one is 1 subsection 1 is x plus 5 is equal to 9. Okay, so transposition, as I said, left hand side, right hand side, you have to keep x this side because that's what you need to find. So you have to transpose number 5. When it goes that side, the sign will change, it's plus, it becomes minus. So x equals to 9 minus 5. So x equals to 4. Okay, and they are saying check your answer. How can you check your answer? What is the value of x? 4, right? So how do you check your answer? So this will be 4 plus 5 is equal to 9. Is this true? 4 plus 5 is 9. 9. It is an equation that is balanced. So x is nothing but 4. This is what they mean by checking your answer. Okay. Homework. Homework will be number 2. Okay. Now I'll try to do number 3. Number 3 is x plus 3 upon 5, 4 upon 5. Okay, so this x equals to 4 upon 5 minus 3 upon 5. This whole thing is going this side, the sign changes. When two fractions meet, and if it's multiplication, you multiply directly. If it's division, reciprocal, then multiplication directly, numerator versus numerator, denominator versus denominator. If reduction is to take place, you need to do that also. But whenever two fractions meet, and if it's an addition or a subtraction, what do you need to do with the whole? What would be your next step? LCM of your denominators. But in our case, we are lucky, since both of them are 5, the LCM will be 5 only. Okay, so this will be 4 minus 3. So the value of x is 1 by 5. Okay, so you can check your answers similarly. Okay, I'm not going to do all the checking your answer part. Okay, we're just going to solve this, right? You can check your answers. If you do this, x is 1 by 5, we add it up, it will come to C. Okay, let me just do it since I'm doing this right now. So value of x is 1 by 5. So x plus 3 by 5 is equal to 4 by 5. So 1 by 5 plus 3 by 5 is equal to 4 by 5. So as I told you, addition, both the denominators are the same. So LCM is 1. 3 plus 1 is 4 by 5 is equal to 4. You can see that. Okay. So that's the way it is, children. Homework. Your homework will be 1 subsection. I think I've already given you 2. Then we have, I've done 3. I did 1 and 3. You'll do 2, 5 and 7. Okay. Now, number 2. Solve each equation, check your answer. Okay. If you go to page number 168, solve the equation 5a into 30. That is example 3. In page number 168, it says 5a is equal to 30. So what do you do? This is multiplying. Okay. But again, we have to keep a this side. You have to find the value of a. That means you have to transpose number 5 that side. So when you do that, since it's multiplying, when it goes that side, it will divide. Okay, so value of a will be 6, right? So that's the way we can do. Now we will move on to number 2, exercise 10a, page number 171. I think page 171. So number 2. Number 2, 1 is 3y is equal to 9. So what do we do? Y is equal to 9 divided by 3. 3 ones are 3, 3 is 9. So the value of y is 3. Okay. Number 2, is your homework. Number 3 I will do. Number 3 states minus 7a is equal to number 2. You do number 2, 3 and 4 for homework. Okay, you do this on your own. Homework will be 2, 3 and 4. Okay, I'm not going to give you too much. This is just for practice. Because these are similar sums, and I'll do one that will be a little bit different, which should, I think, again we have a very unique alphabet J. I don't see this alphabet too much in maths. It's always X and Y and A and B. So how do we go about it? Okay, so J equals to, since 7 is dividing, when it goes that side it will multiply. Okay, so your homework will be just one more for this. Okay, number 6. Right, so it says, children, I can solve all the problems myself, but where's the practice for you guys? You need to do that also. Okay, so I'll do 2 or 3 more sums because we don't have much of time right now. Okay, the question 3 states, question number 3 states, write the following statements in equation form. Find numerals to make true statements. Okay, now the first one is given, the sum of 5 and x is 12. So 5 plus x equals 12. It's given as the sum of 5 and x is 12. So x equals to 12 minus 5, which is 7. Okay, so this is what the question is telling you. Write the following statements in equation form. Find the numerals to make the statements true. Okay, so I'm going to do number 2. This is number 1. I'm going to do number 2. Okay, number 2 is x decreased by 7 is 13. X decreased by 7 is equal to 13. Okay, so x is equal to 13 plus 7. So that would come to, how much would that come to? 13 plus 7 is 20. Okay, so I would love if you would do from number 2 till number 10. Okay, yeah, I think if you can manage it from 2 till 10. Anyways, I'll be posting number 3 to 10. I'll be posting it, the answers, on my WhatsApp page later on. Okay, so 3, your homework will be 3, 4, 5, 6, 7, 8, 9, 10. Okay, children, why am I doing this is for your practice, because later on there will be sums, will be statements will be given. You'll have to form an equation and solve it. Just a beginning. That's why this will be a practice, because if I keep doing all, you will hardly have any practice, right? Listening to someone and understanding and doing it on your own is a sea of difference. Like when you're learning how to drive a car, the theory given, you can learn the theory in 2 minutes, but to actually learn how to drive a car, it takes time. Some people learn it within a day or 2, some people take a week, some people take months, some people take a year also. So it depends from people to people. So if you practice, it will be better. So I'll be posting whatever content that will be remaining on this exercise. I'll be posting it on WhatsApp. Thank you, children. Have a nice day.